Hello, good morning or good afternoon, Solomon. I'm glad you're here, Solomon, because I actually investigated the question you asked on Thursday. Hello, Bikal. Wait, a few minutes for more people to join us, but you asked a good question on Thursday, to which I didn't know the answer. I told you something which turned out to be wrong, but I did investigate, and I could talk about what I found. This is in terms of imputing values and imputing Boolean values and imputing non-Boolean values. So, hello, Linza, how are you? Hello, Ikra, how are you? Hello, Ajasa, good evening to you too. It's Russ, by the way, Russ, but that's all right. So, good morning or good afternoon or indeed good evening to you, depending upon where you are. Hello, Stella. How are you doing today? Hello, Sanjay from India. Hello, Julius. I'm doing well today. It's a bit warm here in Maryland. I went out for a walk earlier this morning and with my wife, and boy, it was warm and humid out there. Hello, Nitin from India. So yeah, we kind of cut our walk somewhat short this morning just because, as I said, it was hot and humid. But no, I'm doing well today. Julius from Nigeria. At some point, I am going to have to take a trip to Africa and visit places like Nigeria and Kenya and Tunisia and Egypt. But of course, right now, traveling is a bit difficult, or I wouldn't want to travel, let's say. So, excuse me. Make this window larger here, at least for myself. Maybe make the text a bit larger. So, it's a few minutes past the hour now here. A couple of things. So, just to remind you, right, on Thursday we talked about the second question in this ML mini project. So the first question, right, we built this simple estimator to estimate the amount of fines that a nursing home might receive, assuming they were given a fine. This was this somewhat simple state estimator. So hello to Niresh, hello to Samson from Nigeria, hello to Ejemanu, or is it Emmanuel? I can't remember. Apologies here. So remember, we had this state model for the amount of fines. We basically grouped our data by state, and we said, well, if a facility received a fine, it's going to receive a fine based on what state it's in, based on this mean. But the main point of this exercise, I think, was to demonstrate how you can build your own custom estimator in scikit-learn. Uh, right, to build your own estimator in scikit-learn, we're going to inherit from these two classes here, well, because we're making a regressor. So we inherit from the base estimator class, and we inherit from this regressor mixin class, because we're predicting a continuous variable. And like we said, the main thing for the estimator is that you need to define this fit and predict method. And you can, often you will define an init method, right? Because you might pass parameters to this estimator when you make it. So you could define an init method to set some things up. You define a fit method, which will take your training data and compute whatever you want in the estimator. The estimator just needs to return self. And the predict method, again, well, you give it a feature matrix and you just need to return one prediction for each value. This is a live office hour, so I'm just reminding you of these things. The important bits for this mini project. This simple features model, right? We wanted to now predict whether a facility is going to be fined or not, right? This categorical feature is based on these particular features of this nursing home. Is this going to be fined, yes or no? That's a excuse me, that's a classification procedure that we want to that we want to build here. We selected a bunch of these features. We had some Boolean features. We had some continuous features here. So we decided there was a collection of columns that we're going to use to build this model. And then we built this custom transformer. Again, this is part of the reason for this example, is to give you an example of how you can build a custom transformer in scikit-learn. Hello to you, Tosin. So we actually provided this column select transformer for you. To build a column select transformer, well, you want to inherit from this base estimator and transformer mixin. And again, a transformer should define a fit method and should define a transform method. And as the name implies here, right, the column select transformer is just saying, well, I want to only use a subset of the columns from this data frame. Hello, Uchichukwu. How are you doing today? Right, so we just want to use this subset of columns. And that's what the column select transformer does for us. We are passing it a data frame or possibly a list of dictionaries, which we will convert into a data frame. And then column select transformer just pulls these columns from the data. And then we talked about missing data. There are some values here in this data that are missing in some of these columns. And we need to impute values in for this missing data. And we talked a little bit about how we could, different strategies we could use to impute values. Now, if they are, where was this? Sorry for scrolling. Right, if we have a continuous value we might use the mean or the median to impute that value from missing data. If we have a categorical feature, let's use the mode or the most common value to impute for that feature. And we did that here. We could use this down here, we could use this simple imputer. And we could stick this into our pipeline, which will process our features. So we select our columns, we use the simple imputer to fill in missing values. Now, Solomon asked a good question, which I investigated afterwards, and I wanted to talk about here now for a few reasons. Because one, it's good to know what these transformers are actually doing behind the scenes, right, in order to make sure that you're using them well. So what I'm going to do here, let's make some small data frame. So let's make a couple of columns. I'm going to put in some Boolean values here. Maybe there's a missing value in this column. And I'm going to make a second column in this data frame which has numeric values in it. So maybe I have a missing value in the second row, 10 and 15, say. So if I create my data frame here, so again, this is just a small example to demonstrate what I want to talk about here. So this data frame right here has 5 rows in it and 2 columns. Now there's one missing value here in this first column. And this first column, say, this is a categorical variable, right? It's true or false. In this case, I could have chosen, say, 0 or 1, or two distinct values, right? But this first column is categorical. This second column right here is numeric. Is a continuous value. Maybe I'll change one of these values so it's actually has something after the decimal point. So as I said, the first column here is categorical, the second column is numeric. Now what we want to figure out right here is what's going to happen if I use this simple imputer on this data frame where I have both categorical features and numeric features. And this is a question that Solomon asked me last week, and he said, well, what's going to happen if, say, for these missing values in the categorical and the true false, is it going to impute a number, or is it going to impute a categorical feature? And well, the answer is it depends on how you specify your simple imputer. Now this simple imputer has a strategy that we can select. There's a few different strategies that we can select. The default value is mean. So remember, if we look at this documentation, let me make this page a little bit larger. So this this default value for strategy right here is mean. So if you don't specify a strategy, this is the default strategy that's going to be used. And if we look down below right here, we could see, let me scroll to get past my lovely visions on the right. Right, it says, if mean, replace missing values using the mean along each column. Can only be used with numeric data. If median, replace missing values with median. If most frequent, replace missing using the most frequent value along each column. There's a constant option. We could replace missing values with this fill value that we could specify. So if we use this strategy being mean, so I will define my imputer, and if I call fit and transform on my data, my small data frame that I've defined here, we can see what happens. And, you know, I guess we have to ask ourselves, is this what we want to happen? Now, there's a few things to notice. One is that this first column right here, these true-false values, the simple imputer has basically interpreted true as 1 and false as 0. And then what's happened for this missing value in the fourth row, this missing value right here in the first column in row 4, what has a simple imputer done? Well, as I said, it has interpreted false as 0 and true as 1, and then it's computed a mean of these 4, 0, 1 values, and it's imputed that value in for this missing value in the first column. So that's why we have this 0.75 showing up in column 1 for this missing value. The missing value in column 2, well, that has been filled in with the mean of 2 and 2 and 10.6 and 15. So, you know, we'd have to ask ourselves, well, is this what we want to happen in column 1? Right, column 1, well, we would probably want to treat this as a categorical feature and impute either a true value or false value based on, say, what is the most frequent in this column. But by using this mean strategy, as we said, scikit-learn, the transformer has interpreted false as 0 and true as 1, and then it's imputed the mean of these 4 values in that column, right? I have 1 0 and 3 1s. So the mean of those 4 values is 3/4 or 0.75, and it's imputed that missing value for what was a categorical variable in that column. If I tried this the other way, so simple imputer, if I said strategy is most frequent, and then I called fit transform on my test data here, well, we'll see what we get is now in the first column, this missing value has been imputed as true. And in the second column, this missing value has been imputed as the value 2, because that is the most frequent value that's in that second column, right? I have a 2, a 2, a 10.6, and a 15. So, right, as I said, one strategy, mean, will treat the true-false as 0, 1 and impute the mean of the non-missing 0, 1s in column 1. And that may not be what I want. This other strategy, most frequent, will now say it might correctly impute a value I want in column 1, but now it's filling in this most frequent value in column 2 in my categorical features. In my continuous features, on my numeric features. And so I may want one behavior in one column and one behavior in a different column, right? I may want the most frequent in column 1 in the first column, and I may want the mean in the second column. And using one instance of the simple imputer isn't going to do that for me. I would need to use 2 of them. And this is where there's another scikit-learn transformer which will help me out. There is if I remember correctly, it lies in this compose sub-library. There's a transformer that is the column transformer. And what this actually allows me to do is I could apply different transformers on different columns of my data. And I could use this column transformer in the following fashion. I pass it a list of tuples. I have 3 values in these tuples. Strategy. So I pass this column transformer a list of tuples, and each tuple has 3 elements in it. The first element in my tuple is a string, which I can use to identify this particular portion of my column transformer. The second element in my tuple is the transformer. And the third element is a list of columns. Mikhail asked the question, can't we use a feature union? Yes, you can also use a feature union. The column transformer is essentially doing a kind of feature union for you. If I could spell strategy today, that might help. But what I could do is I could specify, so I have one column in this case that I want to treat as categorical. And I have one column here that I could treat as, that I want to treat as numeric. I could say a little bit about the difference between column transformer and feature union in a moment. So I can specify this column transformer. And I can pass my data to this, and well, now I have what I wanted, right? My first column, I'm imputing a categorical feature for the missing value. My second column, I am imputing the mean for my numerical feature. Right, and the idea of the column transformer is, well, you apply, so in this case, we'll take this one column, apply this transformer to one column, and we'll get that one column as output. We'll take this other column, apply a different transformer to that column and get an output, and then the transformer basically pastes these two columns together as a new feature matrix. Right, and that's what it's done here. So we take the one column as output for this first simple imputer and the second column from output from the second simple imputer and paste them together into this new feature matrix with 5 rows and 2 columns. If I wanted to, I could say add in more columns, and I could actually reuse some of these columns. Maybe I want to add on some polynomial features. Sorry, I guess I would need to first impute my missing data, and then I would need to put this, into some other transformer to to add some polynomial features, say, to the second portion of the data. So someone asked, well, what's the difference? Can we use a feature union? Yes. Someone is saying, what's the difference between column transformer and feature union? On some level, I mean, there's not a whole lot of difference, but there are some differences. If I come up here, I could, so column transformer, and if I could type in spell today, that would help. So this is my documentation for my column transformer. Right, as it says here, I pass it a list of transformers where each transformer is a list of tuples. So I have a name, a transformer, and some columns. One thing that's useful in the column transformer is there's this hyperparameter, if you like, that's called remainder. And the idea for remainder is you could, if you specify a list of transformers, by default, scikit-learn will drop any columns which aren't used by any of the transformers. But you could change the value of remainder you could change the value of remainder, say, to pass through, or even give some other estimator. So it says here, by specifying remainder equals pass through, all columns that were not specified in transformers will be automatically passed through. It will concatenate these columns to the end of the transformed data. And so this might be one reason why I might use the column transformer, say, instead of feature union. Right? I might want to transform some columns in one fashion, some other columns in another fashion, and I might want to just leave some columns untouched, but I might want to keep those columns in my feature matrix. So if I use this column transformer, I could use this pass-through method. And as I said, all columns that were not specified in transformers will be automatically passed through. Or if you wanted to do so, as it says, you could even specify some kind of estimator which will apply to the remaining columns. How can we automatize this, like writing a function where it can itself identify if it is continuous or categorical column by itself and impute? Unfortunately, I don't think there's an easy way to determine or to make this kind of process automatic, to say, well, this column is categorical and this column is continuous. I mean, you might try and write some sort of function which will examine a column and say, well, are there floating point numbers in this column? And then you might treat that column as continuous. But there might be some danger in doing that because, say, if you read data in using the read CSV method, then pandas will basically tend to treat data as numbers. I mean, yeah, you could try to examine the data types. But as I said, if you read data in using the read CSV method, unless you specify data types, pandas might kind of interpret some of the data to be, of a different data type than you might want it to. If we look at feature union, well, again, so a feature union, as it says, concatenates results of multiple transformer objects. So it says applies a list of transformer objects in parallel, concatenates the results, useful to combine several feature extraction mechanisms. And so, yeah, on some level, it's similar. But if you want to apply transformers to different sets of columns, there's not a particularly good way of doing that in the feature union itself. You would need to specify which columns the transformer is going to apply to within the transformer itself. Right, with a column transformer, well, I could say use only this column or this set of columns for this particular transformer. The feature union wants to apply every transformer to every column in the matrix. So if you wanted to use a feature union to apply different transformers to different sets of columns, well, then what you might need to use is something like this column select transformer that we've defined earlier. Where is this column select transformer? Right, I might say, well, here's a data frame, select these columns. That's step 1 in my pipeline. All right, step 2, apply this transformer to this particular set of columns. All right, that could be like one sort of 2-step transformer, right? Select some columns and then apply this transformer to those columns that I've selected. Another thing I could do is, well, I could say, well, select this other set of columns, apply this different transformer to these columns, and then I could use a feature union to paste these together. But what the column transformer allows you to do is to specify which columns you want to use inside the column transformer method itself. right? I just specify which column or columns I want to use as part of this tuple in my column transformer. So I think, in a sense, the column transformer is actually probably easier to use than the feature union. If I don't have a data frame, then instead of column names of data frames, I could specify numeric indices, right? Use column 0 or column 2 or column 1. I should be able to do this here as well. I could specify numeric indices in my column transformer, and I get the exact same result as before, right? Because this will take the first column, the column with index 0, and this will take the column with index 1 right here. So I said, I think if you could use it, the column transformer is actually easier to use than a feature union. Because, I could just specify which a column or columns that I want to use. And these can actually be repeated. I could use both column 0 and 1 right here for this simple imputer. And, I could use the same column for some other transformer if I wanted to do so. I'm not sure why I want to do that in this case, but if I wanted to do that, I could use columns, the same columns in more than one of these transformers. Can we please replace remainder equals simple imputer strategy mean with the last tuple in our feature entrance feature? I see. So instead of specifying this transformer here, you're saying I can do remainder equals simple imputer strategy equals mean. Let's see here. Oh, I'm missing my column. What am I doing wrong in the syntax? Apologies. Column transformer with mixed types. Remainder. What they're saying is, well, the documentation is saying you should be able to use a transformer here for the remainder. Remainder equals drop or pass through or estimator. Using this feature requires the data frame columns input at fit and transform have identical order. I will need to maybe I need to specify this as a string. All right, well, let me investigate this, and I'll see if I can find out why this isn't working how I expect it to work. You can see, well, I don't think I've ever actually used this remainder other than drop or pass through, so I shall double check and can get back to you tomorrow on this. So because says, why do we use machine learning when we have deep learning ones? Machine learning models, well, we don't require all the machinery that deep learning ones models have. A lot of the time we could use these more simple machine learning models and get as good results as deep learning. Hang on. There we go. So I needed to close the list of tuples first, and then I needed to add the remainder equal strategy imputer at the end outside of the list of tuples. So I just, as I said, I needed to close my list of tuples first, right? So there's a list of tuples. I needed to close the list, and then I can specify remainder as an estimator in this case. And so this will impute the most frequent value for this missing value in this first column, and it applies the mean strategy to the remaining columns, which is only one column in this case. What if you want to transform, you only want to transform a slice of the column? I'm not sure what you mean. If you only wanted to transform a set of rows and a column, well, we don't really typically do that in machine learning feature engineering, right? I'm going to apply a transformer to a whole column or set of columns. So you can only really specify columns, a column or set of columns, and when you specify columns in the column transformer. You can't only specify like a portion of the rows. That's not how these transformers are set up. If you only wanted to transform the first few rows of a column, you're going to have to, say, write your own kind of transformer which will do that type of thing. As I said, the transformers in scikit-learn are set up to operate on one column or a set of columns, and all the rows in that column, not only the first 5 rows or something of this form. You could specify a slice of columns. Yeah. So Adebayo, you could specify a slice of columns. You should be able to. Oh, I see. Hang on. Well, you'd want to do. Sorry, this is going to take a list. So you would need to use something like range to specify a slice. If I use range, well, I don't need to put it inside a list because it's going to be a list of lists. Only a list or slice. Alright, so I'm going to need to return this as a list. So this argument right here, it could be you can't specify it as a slice. The columns, it says, this could be a string, array like of string, int, array, int, etc., etc. If the headings and the columns contain strings, how do they transform it? Well, as I said, if you are specifying if you're passing this a data frame, if I'm giving this a data frame, I could just specify names of columns. If I get all my parentheses in the correct place. Here we go. Right, I could give, I could give a column name of a data frame if I know my input is going to be in the form of a data frame. Right, so this list right here, you just specify a list. If you know your input's going to be in the form of a data frame and you know the names of the columns, you could specify that list of names, of column names. If this is, or you could specify using numbers, right? 0, 1, 2, 3, or some, collection of numbers. I could say 0 and 1 here. And then this will use both columns of my original data frame. This remainder won't apply then, because both columns will be used for this first simple imputer. If I only apply the 0, then most frequent will apply to the first column, and the mean will be used in the second column. So, right, you could specify this in many different ways. So I said, if you know your input's going to be a data frame and you know the names of the columns in the data frame, you could specify those names in this list. If I want to apply this to both of my columns, well, I could apply those, both of those column names in here. If I only specify one of them, then again, well, this remainder here will apply. If I change this remainder here to drop, well, then this will only transform the first column and it will drop the second column because the second column hasn't been used by any transformer. If I were to specify remainder instead, well, it will pass through, remainder, pass through, then it will paste the second column, but well, now I still have a missing value, which I would still need to deal with before I could pass this to a machine learning algorithm. So I said, provided you can get your syntax correct, then the column transformer I think is easier to use than the feature union. Because the feature union, you're effectively going to have two steps for every transformer. You say, well, I want only these columns, and then I apply the transformer to those columns. Whereas the column transformer, you specify the column or columns. Yes, a good question, Solomon. Yes, the column transformer has a named transformers dictionary, right? And this is where the strings that you specify come in, right? Named transformers, right? Then this is a dictionary, and you could pick out one of those transformers. So this is effectively why you specify a string, because then you could access individual transformers, say, and get, you could get the values out from the transformers. Or maybe you want to apply one of those transformers, by itself for some reason. So yes, this does have, it's not named steps. Named steps is for a pipeline. For this column transformer, there's named transformers. And as I said, this is a dictionary, and you could, look at those individual transformers in this case. So any other questions about this column transformer? As I said, I think this is more straightforward to use over a feature union, because I could put several transformers together, say, oh, use this transformer on columns 0, 2, and 3, use this other transformer on columns 1 and 5, have the remainder as pass-through, and then scikit-learn will run all these transformers for me on the various columns and paste together the result at the end. Column transformer applies in series or in parallel. But as I said, if you wanted to, for some reason, you could have one column appear in multiple transformers in the column transformer if you want to do so. Like, they don't have to, these lists that you specify of columns, they don't have to be distinct from one another. No column transformer. So let's, I could put things together here. Let's suppose I want to do a couple of things. Let's suppose that I want to create a pipeline. First, I will impute my features. Right, I'll impute some missing values, and then maybe I want to do some polynomial features. I want to do poly, and maybe I only want to do poly on my transformer. Let's suppose I only want to do polynomial features. So, all right, or yes, there's someone saying, so let's scale. So, but I only want to scale on the numeric column, not on the, so I want to use a standard scaler, which I might need to import. So let me import this from sklearn.preprocessing import standard scalar. I'll do a standard scalar. And so I need a tuple. So I need a list of tuples. I want to apply this to my that and that and that. And if I do my fancy features, and I need to add a remainder equals pass through. Right, so I have a pipeline which first I call my features column transformer, which will do this imputation of values. And now I want to scale my numeric column. So I have a standard scalar, but I only want to apply it to my numeric column. And I'm going to keep my categorical feature, and you can see the output we get here, right? The remainder being passed through, what scikit-learn is it will apply the column transformer, the standard scalar, to the numeric feature, and the remaining columns are added on to the end, right? This is why you have the true-false coming out here at the end. Because the columns that aren't used by this second column transformer are pasted on to the end of the resulting feature matrix. But yeah, I kind of need to do the pipeline here because first I need to impute missing values. In particular, I need to impute a missing value for that numeric feature. And then only after I've imputed the missing value for the numeric feature, then I want to scale it. So I would need to do these things, in the proper order. I would need to do, as I said, I need to do the imputation first. And now all my values. Well, if I wanted to do polynomial features, I can do polynomial features here instead of standard scalar. So I could import polynomial features. I can say I want polynomial features here. Let's call this scale instead of poly, and I can specify a degree in here or use whatever the default is. And right, I have polynomial features on my numeric column. If I wanted higher degree polynomials, well, I could specify a degree and get higher degree polynomials. Of course, if I wanted to do polynomial features and then scale things, well, then I would need to add another step into my pipeline. And I might only want to do, scaling on my numeric features, and so I would have to specify which columns to scale. Right, so you could put these things together in very complicated fashions. I could right? This features right here is a column transformer. Well, I've used that inside of a pipeline. I have another column transformer here. Well, I could, specify some separate pipeline and, or column transformer and stick it inside this pipeline here. So you can basically do what you want. It's just a matter of specifying, which columns you want to operate on. Make sure you have the correct columns everywhere. Right, and especially keeping in mind things like when you use a column transformer with this remainder is passed through, then suddenly this true-false column is at the end. And if I make polynomial features, of course, the size of my matrix grows. And so if I wanted to scale my polynomial features, well, I'd have to know which columns to apply my standard scalar to. So I'm going to end this office hours here for today, as I need to go and do another office hour with another set of students. So thank you very much. And tomorrow we could continue talking about this ML mini project. So yes, happy data